In this video, you will learn how to find values of x for which a given function f of x is undefined. Alright, let's solve this first problem. Let f of x equals 5 ln of x minus 7. Find the values of x for which f of x is undefined. So we're given here this function f of x equals 5 ln of x minus 7. So this is a function with the natural logarithm. So let's recall the domain of the natural logarithm. Let's say the function ln of u. The function ln of u is defined only when u is greater than 0. And in this case, in the given function, our u here is x minus 7. And x minus 7 should be greater than 0 for the function to be defined. And now we can solve for the value of x. It's greater than 0. So the value of x here is greater than 7. So we add 7 to both sides. This cancels out. So that's how we got x greater than 7. So that means this function, a given function here, is defined when x is greater than 7. Or we can write this in interval notation. Okay, that one. Okay, since the function is defined when x is greater than 7, so that means f of x is undefined when x is less than or equal to 7, the opposite of this one. Right. Alright, given the same function, given that point P has coordinates P0, find the value of P. So again, our function is f of x equals 5 ln of x minus 7. And it is stated here in the problem that point P has coordinates P0. So the x value here is P and the y value is equal to 0. So that means point P lies on the graph of f of x. So f of P is equal to 0. Then we can write our function as f of P equals 5 ln of P minus 7. Since f of P is equal to 0, therefore 5 ln of P minus 7 is also equal to 0. Then we can solve P from here. So we divide both sides by 5. Then we have ln of P minus 7 equals 0. And then we can use the property of natural logarithm. So we can write this as e to the ln of P minus 7 equals e to the 0. Let's recall from the properties of natural logarithm, e to the ln of x is just equal to x. Therefore, e to the ln of P minus 7 is just equal to P minus 7 equals e to the 0 is 1. And now we can solve for the value of P from here. So let me delete this. So P minus 7 equals 1. We add 7 to both sides. Therefore, the value of P is equal to 8. Now let's solve another problem. Let f of x equals ln of x over 3 minus 1. Find the values of x for which f of x is undefined. So the same thing. We're given here a function with a natural logarithm. So let's recall the logarithm rule. So ln of u is defined only when u is greater than 0. And in this case, in our given function, our u is this one, x minus 3. So u is equal to x over 3 minus 1. And u is greater than 0, therefore x over 3 minus 1 is also greater than 0. And then we can solve for x. So x over 3 minus 1 greater than 0. Then we add 1 to both sides. Then we have x over 3 greater than 1. We multiply both sides by 3. Then we have x greater than 3. So that means this function is defined when x is greater than 3. And that also means that, okay, the function f of x is undefined when x, the value of x is the opposite. So that would be when x is less than or equal to 3. Right. And for question B of the same problem, the same function, given that point A has coordinates a 0, find the value of A. So the same function f of x equals ln of x over 3 minus 1. And then given the point A with coordinates a 0. So A here is the x value and 0 is the y value. Okay, and this also means that the given point A here lies on the graph of the function f of x equals ln of x over 3 minus 1. Therefore, f of A is equal to 0. Then we can write our function as f of A equals ln of, we replace x with A because the value of x is A from the given point, A over 3 minus 1. And this is equal to 0. Now we can solve for the value of A. So that is ln of A over 3 minus 1 equals 0. And then we use the property of natural logarithm. Let's recall e to the ln of x is equal to x. So we can write this as e to the ln of A over 3 minus 1 equals e to the 0. So this is just A over 3 minus 1 equals 1. And then we add 1 to both sides. Then we have, let me delete this. Then we have A over 3 equals 2. And then we multiply both sides by 3. So this is just A equals 6. Therefore, the value of A is equal to 6 given the point A, which has a coordinates a 0. So this is just 6, 0.